back. This is problem 4, section 3.7. This is the last problem in this section on web work for us. Find the point P on the graph of the function y equals square root x closest to the point 2, 0. Okay, we have seen a problem similar to this. Closest means you want to minimize the distance. Distance function has a square root in it, so it's better to take the square of it. So you want to find the point where distance square is minimum. All right, basically closest means distance is minimum. So the curve is y equals square root x. Y equals square root x, you have seen this already in your earlier classes, looks like this. The point 2, 0 is not on our curve. In fact, it is somewhere away from the curve. So you want to find the point that is closest on this curve to it. So it will be somewhere here, like that. You understand? So you want to figure out that particular point. So the point, to find the point P on the graph y equals radical x that is closest to the point 2, 0, we need to find the point xy whose distance from 2, 0 is minimum. By the distance formula, distance between any 2 points is given by square root x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Notice some people write x2 minus x1, y2 minus. It's okay. You're squaring it, so it doesn't matter. The order doesn't matter. You're squaring it. But notice the distance formula comes with a square root symbol. So derivative etc. is harder with a square root. So why not take the square of it? To minimize d, it is easier to minimize d squared. So consider d squared, that is get rid of the square root. Now you have this function. Our points are xy somewhere here, and the second point is 2, 0. Okay, 2, 0. So x minus 2 quantity squared plus y minus 0 quantity squared. Okay, so which gives me x minus 2 quantity squared plus y squared. I want to minimize this function, but notice I have two variables here. It's ideal if you can replace one of the variables. So y is square root x, we already know that. So why don't we use that? I'll take square root x instead of y and square it. That gives me x. Okay, so d squared is x minus 2 quantity squared plus x. Okay, square root x quantity squared. So take its derivative. The 2 comes down and you have to use chain rule. Derivative of the object inside, that's just a 1, plus derivative of x is just a 1. So multiplying by 1 doesn't change anything. Derivative is 2 times x minus 2 plus 1. Distribute 2x minus 4 plus 1. 2x minus 3. So to find the critical numbers, I'll have to set it to 0 because this is always defined. It is never going to be undefined. So the only way to get critical number is by setting it equals 0. Solving for x, move the 3 away, divide by 2, you get 3 over 2. What about second derivative? Second derivative is positive 2, concave up. So in other words, I get x equals 3 halves is a minimum by concavity test. If you recall, concavity test does the following, you see. I have 3 halves somewhere here. Oops. Okay. Somewhere here is 3 halves. And my function is not concave down. It is concave up. So this has to be a minimum for me. All right. So x coordinate has to be 3 halves. Submit. We are done. Okay. So that completes section 3.7. My next set of videos will be on section 3.8. Until then, bye.